Hey, what is up guys? My name is Denon and today I'm going to show you how to do basic dynamic analysis on a malware. So first up, what is basic dynamic analysis? Well, basic dynamic analysis is to execute the malware in a safe and contained environment and see what a malware would do. We then observe its behavior when executed in order to determine the functionality of the malware. So what are some stuff that we have to look out for are the changes to the registry and the files being created by the malware. So there are many tools that can be used in basic dynamic analysis, and the first tool that I use is a cloud sandbox. Well, cloud sandbox is basically there's multiple VMs hosted in the cloud, and then there will be a website for you to visit, for example as shown here in www.hybridanalysis.com. So what I do is I upload the malware onto the website. The website then sends the malware to the VMs in the cloud, and then they execute the malware from there. After that, then I think they would have some artificial intelligence to pick up the relevant information from the VMs and presented it into a report, and then it will be shown to the user. This is an automation of basic static analysis and basic dynamic analysis. So the next tool that I used is Ragshot. So basically how Ragshot works is that it takes two registry snapshots at different timing. For example, one before the execution of the malware, and another one which is after the execution of the malware, in order to compare the amount of registry entries that have been changed. Well, by analyzing these registry changes, we are able to find out more about the purpose of the malware. Next up, we have Process Explorer. Well, Process Explorer is able to monitor all processes running in the virtual machine. For each process, we are able to view the mutexes created, the handles and DLLs being loaded, relevant strings in the process, and determine processes are being created or deleted by the malware when the malware is executed. Next, we have Process Monitor. Well, it is able to monitor file system, registries being modified, and network activities exhibited by different type of processes running in the machine in real time. So if we execute the malware, we are able to view how the malware executes itself step by step using Process Monitor. Next, we have Apartheid DNS. So Apartheid DNS spoofs DNS response to a user's specified IP address, for example a local host address of 127.0.0.1. The purpose of Apartheid DNS is to simulate a network within a single host in order to fool the malware into thinking that it is a legitimate network. Well, this then allows the malware to review its network functionalities. Next, we have Netcat. Netcat is a tool to monitor inward and outward connections at a specified port. From Netcat, we are able to determine whether data had been transferred remotely or not. So now, let's move on to the VM. And guys, now we are in the VM. So first thing first, I'm going to set up my Apartheid DNS and set my DNS reply IP to my local host address to 127.0.0.1, and let me start the Apartheid DNS server. The server has been started and let me run the malware. So as you can see in Process Explorer, the malware.exe has been created, and from Process Explorer we can see that there is no other services or processes being created or deleted when the malware is executed and running in the background. So what we can do now is take a second shot of Ragshot and let it do its thing, and let us move on to view the DLLs and the handles in malware.exe. So first up, let's view at the DLLs of malware.exe. So these are the DLLs being loaded by malware.exe, and two noticeable ones are mswsock.dll and wshtcpip.dll. So mswsock.dll is a Microsoft Windows Socket 2.0 service provider. This DL, the malware might try to establish a network connection through a socket through this DLL, and based on my research that this DLL is able to manipulate other program files having a 16% dangerous rating, and also wshtcpip.dll is a Windows Sockets Helper DLL, which again also proves that the malware might also try to establish a network connection. So now let's view at the handles. So one noticeable one right away is this key right here, which is hkcu/software/microsoft/windows/current version/run. This suspicious registry key has been added. It might be for the malware to execute automatically when Windows is booted up, since between has a run registry hive. And another interesting thing that there is no mutex or mutant being created by malware.exe. Mutants are used by malware to avoid reinfection on the same host. Since there is no mutexes being created over here, we can conclude that the malware would still infect the same system if executed multiple times. Now let's move on to rec shot. As after you can see the first shot, I had clicked on the first shots before executing the malware, and the second shot after running the malware.exe, and now we're gonna compare. And these are the registries that has been changed. And right off the bat, you can see that this registry key is very suspicious, since the registry key of software/microsoft/windows/current/run/microsoft syslog. This Microsoft syslog is added to the run registry hive, which the malware might able to establish persistence by automatically running when Windows is booted up, and has created a suspicious syslog.exe file to the C drive/windows/syslog.exe at C drive/windows directory. Yep. So other things. Now we're gonna move on to process monitor. So as you can see in process monitor, there are many process being monitored by Process Explorer, and now we're just gonna filter out the one that we want, which is the malware.exe. And let me just add a filter. And now we are trying to find out whether the malware.exe has created any files or had accessed any files. So we are just gonna add a few more conditions to it. So operation equals to create file, and we add that, and close file, and write file, and add, and I'm gonna click OK and let the event filter do its thing. Yep, the reason why I chose a write file is that to see whether the malware has written anything to a particular destination, close file whereby where the malware has successfully read the file and then closed it, and create file when the malware might tries to open any file, and I would like to find out whether the malware had actually done these 3 commands. Oh. Yep. I think I'm just gonna edit this thing. Oh, yep, it's done. And let's move on to C. Let me analyze the code. And yep, as you can see, it has created a file at C drive windows/windows syslog.exe. And syslog.exe, and let's go to that particular file directory, shall we? So it's at C drive windows syslog.exe. There it is. And let's compare. And let's properties. This is the properties of syslog.exe, and this is the properties of malware.exe. As you can see, it is really similar, whereas the size is 10.5 KB and its size is 10.5 KB, size only is 12 KB and 12 KB, and I suspect these two might be the same, but we can't be so sure until we hash them using winmd5.exe. We run that real quick, and just to clear my doubts, I'm going to compare the hashes of malware.exe and syslog.exe, and look, the hashes are the same. So this means that malware.exe and syslog.exe are the same, and I can conclude that malware.exe has duplicated itself and into syslog.exe and has put into the C drive/windows directory, so that these two programs are the same. Now let's get back to process monitor, and now let me remove the operations and let me add rec set value. Let me add rec set value and rec open key. Rec set value and rec open key. Yes, and let's just let it apply. It has finished running, and let's analyze the results, and let's see. Yep, as you can see at rec open key and rec set value, the malware.exe might have opened this registry key and has set a value of Microsoft syslog at the back of this key. So basically what it does is just adding Microsoft syslog to the run registry hive in order for the malware.exe to execute automatically when the user logs on or when the Windows is booted up. Now let's look out for remove and just Okay. And now let's take a look at the other processes being run by malware.exe. As we can see that it's trying to do a TCP connection from its local port of 1166 to an IP address of 100.9.24.10 in-addr.arpa of port 7358. So what I'm gonna do is open command prompt. I'll be using netcat to listen to both ports and to see whether any data has been transmitted. So one will be 1166. We'll be listening to that port, and -L-P of 7358. And we will just wait for the result. Now we will go to Apache DNS to look if there's any results. As you can see, there is a similar result from our process monitor of 100.9.24.10 in-addr.arpa, which is the same. So this means the in-addr.arpa indicates that it's a reverse DNS lookup, thus meaning that the IP is in the reverse order, and hence the real IP address that's trying to connect is actually 10.24.9.100. Yep. And let's take a look at netcat to see if there's any results. As you can see, netcat does not display any results. Does not display any results from these two ports, and I can safely say that no data has been transferred. Oh yeah, and another thing, when you see the malware.exe is always reconnect and keep disconnecting, it's because that this virtual machine has no internet connection. It is not in NAT mode, it is in host only mode, so it does not have any internet connection, thus it will not be able to connect to the IP that it wants. Yep, and that's for all for the tools. And now let's move on to sandboxing. So now we are gonna do sandboxing. So basically this is hybridanalysis.com. I'm just going to upload the malware, and I'm just going to click on terms and conditions and storefront. And yep, and let's try to. We can see that we can choose our available VM machines. We're just gonna go with the default one and generate report. So yeah, as you can see, it has been ran, and let's just analyze this on our host machine. So basically these are the results, and there's a report generator, and let's take a look at the report. And we can see that the malware, there's some malicious indicators. Basically it's just being detected by more than one antivirus engines by VirusTotal. And let's go to the suspicious indicators. That it has been packed by UPX, and it also just to installation persistence. So basically what we have found is actually created syslog.exe, and it's compressed using UPX, and also it has modifies auto execute functionality by creating a value in the registry. by adding Microsoft syslog to this registry key software/Microsoft/Windows/conversion/run, which is to boot up which is to execute the malware whenever the Windows boots up or when the user logs onto the machine, which is the same on what we had seen. And now time for findings. Now for the host-based indicators, the malware actually duplicates itself into the C drive Windows directory and creates a new file called syslog.exe. It also adds Microsoft syslog to a registry key of hku/software/Microsoft/conversion/run in order to establish persistence, so that whenever the user logs on the computer or the Windows boots up, the Microsoft syslog will be executed automatically. Next up, we have network-based indicators. So the malware actually attempts to do a TCP connection to the IP address of 10.24.9.100 off from a random port of 7358. As you can see from Netcat, no data had been transferred. And also from Aparte DNS, a DNS request had been made to 100.9.24.10 inaddr.apa, and some notable functions such as mswsock.dll and wshtcip.ip.dll. So the functionality of the malware is most probably a keylogger. It possibly sends information to the IP address of 10.24.9.100. However, no files are being created to store the keystrokes of the logs. So the malware, when the malware executes, the malware copies itself to the C drive Windows directory. It edits the registry to establish persistence to run automatically when the user logs on, and another interesting thing that it does not create mutex, which might allow the malware to reinfect the same machine over and over again when executed multiple times. However, it also tried to establish connection but failed because the virtual machine has no internet connection. And thank you for your attention. This is Denon signing out.